Welcome to the EK Technology Day 22. In the hardware manufacturing industry, the best way to stay ahead of the curve is to be the very one who bends it. And that's precisely what EK is doing in the field of water cooling. We have the privilege to live in extremely exciting and inspiring times for computer technologies where huge breakthroughs occur almost daily. Blink and you'll miss a new product or even entirely new approach to how computer hardware is made. This is why here at EK we never blink, at least when it comes to following the latest industry standards. In fact, we are the ones who set them, mainly within the domain of liquid cooling. We are all about performance, reliability and focus. Our goal is to bring the production costs of liquid cooling much closer to those of conventional air cooling systems, but without sacrificing the performance and reliability standards we have set over the years. Our R&D department is constantly exploring, improving their know-how and coming up with new approaches that can help our partners achieve their goals. In a collaboration setting, we like to be involved right from the get-go. Only then we can reach the holy trinity of cost reduction, optimal performance and visually stunning design. Our focus also lies in personalization. For every project we do with one of our partners, we have an individual, personal approach tailored strictly to the needs of their customers. Aside from the numerous innovations you're about to see, we also decided to become independent in terms of entire supply chains. From development and knowledge to support and delivery, our products are now available on multiple continents, making sure our customers are not left with burning holes in their pockets and empty slots in their sockets. As for the proof of quality and set innovation, we could boast about numerous awards and prizes our company has won so far, but we don't need to do that. Instead, let's see what the exciting world of liquid cooling has been up to.
Currently, one of the most talked about topics is how to reduce production costs and bring them closer to air cooling. One recent example of using technologies for more industrial purposes is the case of the UltraBlock. The goal was to cover as much of the motherboard as possible with the challenge of having very limited space between the upper CPU part and the lower M.2 and the chipset part. We rummaged around our technology approaches bin to see how we could bridge the gap with a cross-section sufficient enough for the optimal cooling flow. Making this happen by using a single piece of copper or standard milling was not possible. So the following question was asked: why don't we simply use the brazing process to join the top and the bottom water block using copper tubes? It ticks all of the boxes, fits into the space, creates a permanent strong sealed bond, provides the largest possible cross-section for the flow, and we already have a proof of concept. So, no no's. Sounds like an easy win, right? Well, wrong. As always, the devil is in the details. And the details that gave us real headaches was using an industrial solution process for a high-end product that needs to look and feel premium. Although we thought we had all the building blocks to piece things together, we were missing one crucial component: how large surfaces of copper would react to nickel plating while having a brazed joint in the mix. The sample batches went through without any major issues, but when the large-scale production started, problems began popping up one after another. Ultimately, we solved all the issues, reached the desired aesthetics, and delivered the required quantities. But not without delays, which, understandably, didn't make our customer too happy. The moral here is, every time new technologies are introduced, there is an inherent risk of failure. But without pushing the envelope, there wouldn't be any progress to be made.
Now, when you know what tray-brazing liquid cooling technologies we are working on, we should address how we work with our strategic partners to help them get their products they desire and to do so in cost-optimized ways. EK enables its partners to develop the best possible products, especially if we are there from the beginning. With knowledge and experience in cooling system development and manufacturing, we add value to the customer when we are included from the start. The hard truth is that CPUs, GPUs and motherboards are only as efficient as their cooling system. There is no other way around it. And to make the product perform the way customer deserves and expects, as well as to make it cost efficient and designed for manufacturing, it is critical for us to participate from the earliest possible stage. This way, we are able to propose and guide the board design process so the cooling system can fit perfectly. Every final off-the-shelf solution that you develop and offer it to an enterprise customer involves some type of compromise. The customer will almost always want something different. So even though we have off-the-shelf solutions available, our aim and focus are to be a development partner with our customers. We want to tailor the product to meet the customer needs and requirements perfectly. This is only possible when we develop product together in a close collaboration type of setting.
The third crucial driving force after performance and reliability is design, an integral part in the development of our technologies and solutions, evident from the evolution of our products over the last 15 years. Water blocks have transformed from pragmatic and straightforward 2.5D shapes to perfectly fitted, clean assemblies with a wide range of features and materials. Packaging all of those requirements into a minimalistic design is a real challenge, especially when pursuing excellence in every detail. In the case of our latest CPU block release, Velocity 2, we wanted to achieve a completely smooth top with no visible screws or mounting mechanism. At first, the necessary solution sounds simple: attach it from behind the motherboard. However, when factoring in socket specifications and allowable clearances, things became rather complex. Achieving consistent mounting pressure for the CPU block means that it's necessary to use coil springs. If the pressure was too low, the thermal paste would not spread and perform as it should. But if the pressure was too high, the product would not meet the required socket specifications. Furthermore, on the secondary side of the motherboard PCB, there is a height restriction, preventing any significant protrusions. To package the coil springs, it was apparent that they had to be on the primary side. A thumb nut on the back side could then pull on the screw to tension the spring. To make this practical to install in situations where only one side can be seen at once, the detensioning screws are held under load and keyed to prevent rotation. This uniquely allows them to reach the load length of the spring with very little thread engagement. Such short engagement ensures that the block is mounted evenly and simple flanges prevent over-tightening, alleviating common user errors and any rotating parts which might damage the PCB. All these improvements together led to a mounting design which retains and improves upon all expected functionality. It can be implemented across multiple socket specifications with identical parts and crucially stays aesthetically true to the concept. The most successful designs elegantly relate aesthetics, performance, and reliability, elevating all three simultaneously. Often, the simplest solutions are the ones which unite these three pillars. For example, in our new Vector 2 GPU block cooling engine, an element that has continuous focus from a performance perspective, but on this occasion we managed to leverage an improvement from an aesthetic decision. The coolant itself is the most distinctive visual element in a system that instantly communicates something special and powerful lies inside. Second to that element are the cooling fins, so it was only natural to eliminate the stainless steel jet plate which obstructs them both from view. The jet plate is an integral part of the cooling engine, increasing the flow velocity through the fins and providing some obstruction to crudely distribute the flow, so it could not be removed entirely. We decided to combine it with a plexi insert that was previously a very simple 2.5D shape. Since this made it necessary to machine the part, we could deploy a more complex geometry and taper the inlet cavity to better distribute the flow across the fins. The result, a simple visual material change, eliminated one part, improved hydraulic performance, and improved thermal performance by 1.6 degrees.
We hope we managed to bring the magical world of water cooling a little bit closer to you. As the evolution of computer systems moves at record paces, it is important to stay ahead of the proverbial curve we mentioned before. And the safest way to do so in the water cooling industry is to stay in the custom loop with us. At EK, we enjoy elevating computers to new levels of performance, stability, and visual design. But we don't like to do it alone. Each endeavor is much more fun when shared with your friends and partners. so be sure to subscribe through our Technology Day page or contact us for a potential partnership collaboration. Stay cool!